You've probably heard a lot of talk in biotechnology circles lately about something called nanotechnology. Lots of talk about how fullerenes are being used to cure cancer, or how nanopolymers are being integrated into future military body armor. But what is nanotechnology? Who discovered it? And what are some of its potential medical applications? Well, tonight, we're going to try to clear up some of the misconceptions you may have about nanotechnology and perhaps instill you with some genuine excitement over this promising new field. What is nanotechnology? Simply put, nanotechnology deals with the manipulation of materials on the nanoscale. For all the math enthusiasts out there, 1 nanometer is 1/1000th of a meter. For all you non-mathematicians, such a scale is on the order of atoms and small molecules. The idea of manipulating materials on the atomic scale was first brought up in Professor Richard Feynman's famous 1959 theoretical lecture, "There's Plenty of Room at the Bottom." In his lecture, Professor Feynman stated that the current method of industrial manufacturing relied on a top-down approach, where the fabrication of materials relied on methods of macro-scale manipulation, like cutting, welding, and molding. What Professor Feynman proposed was that materials could be manufactured using a bottom-up approach. In such an approach, manufactured materials could be built up from single molecules, their structures being held together by atomic forces much stronger than welded steel. At the time, though, the scientific world did not have the means to manipulate materials on such a small scale. In 1985, however, Harold Kroto, Robert Curl, and Richard Smalley discovered the third form of molecular carbon. The only other forms of molecular carbon known at the time were graphite and diamond. Because of the molecule's peculiar geometric structure of alternating pentagons and hexagons, the team named their discovery the Buckminster fullerene, or just fullerene for short, after Richard Buckminster Fuller, the architect who'd invented the geodesic dome. At the time, such a discovery seemed to have no immediate practical application. In the following years, however, most of the scientific community has recognized Kroto, Curl, and Smalley's research as having paved the way for entirely new fields of study in chemistry and physics, including nanotechnology. Since their discovery, the C60 fullerene has been found to have several peculiar properties that make it suitable as a drug delivery vector in the biomedical field. Some of the C60 fullerene's properties include its relatively small size, its hollow cage-like structure, its strong, flexible covalent bonds, and its 30 unsaturated double bonds. Due to its small size, the C60 fullerene can pass through areas that are normally restricted to larger drugs, areas like the blood-brain barrier. The hollow interior of the fullerene make it useful in trapping viruses and cleaning up rogue molecules, such as the reactive oxygen species, or free radicals. Although C60 fullerenes are certainly the most common form of fullerenes, they are not the only form. Fullerenes can range in size and shape. Scientists are even planning to manipulate the structure of fullerenes into cylindrical structures called nanotubes. Such structures can be used to construct nanomotors, nanomachines, and even macro-scale polymers that might be used for future architectural designs. Well, although we've exhausted our time here today, you can rest assured that we've only begun to scratch the surface of what's possible with nanotechnology. And although this may be the first time you've heard about nanotechnology, I can assure you that it most definitely will not be your last.